All right, so if we are adding f plus g, this is a pretty easy one, right? Because the common denominator is already there. So all we have to do is add the numerators. Easy enough? Okay, they didn't ask, but what would the domain be? All reals except -1, okay? All right, very good. So when you go to divide f and g, what's actually we're going to do here? Yeah, we're going to multiply by the reciprocal of the second guy. So since x plus 1 is in the numerator and factor x plus 1 is in the denominator, those can cancel, and you're left just with 2 over x. Everyone with me there? These guys just kind of slide. All right. What is the domain? X cannot equal 0 or -1. So even though that canceled out, that restriction is still there. Everyone understand that? So you can't just look at the final answer. You have to look at the original question. All right, very good. Let's just do the first one of these. We don't need to do this to death, I don't think. So let's do h of j. So my h function, big bubble for my x, the big bubble for that x, and we're going to plug in my j function. So we talked the other day about expanding the binomial without having to go to the side and FOIL. So first guy is going to be 25x squared. So remember, you square both the number and the x. Multiply them together and double it. What would you get? Negative 10x. And then square the 1. You go ahead and distribute the 6 here. So nothing crazy hard. You just got to take your time and make sure you're distributing properly and adding things right. What's the domain here? The input function was all reals, yes? The output function is still a quadratic, so the domain is all reals. Doesn't change. Okay, so we okay without doing g of h? You feel confident? All right. So today we are going to talk about inverse functions. When is it an inverse function? What does it mean to be an inverse function? How to find inverse functions? How to show that they're inverse functions? All sorts of stuff. Okay, so let's think back for a second. When did we say something was a function? It passes the vertical line test. If I'm looking at a set of points, how do I know if it's a function? Remember our dating rule? The x does not repeat. Okay? So it's a function if the x is paired with unique y and they pass the vertical line test if you have a graph. Today we're going to talk about one-to-one functions. One-to-one functions, the x's cannot repeat, that's why it's a function. The y's cannot repeat, which makes it a one-to-one function. Okay? So nobody's cheating on anybody on these functions. Okay? So in this first graph, you can see at level 3, you've got 2 x values being used with that same y. So although it is a function, it is not a one-to-one function. Over there you can see I would not be able to find a y that's repeated. So that makes that right graph a one-to-one function. So x's don't repeat, that's what makes it a function. The y's don't repeat, that makes it a one-to-one function. Does that make sense? Yes, Mrs. Sparchek. It makes perfect sense. Perfect sense. I don't know where to put this thing. Okay. So, determine if they are functions first. So what about the first one? Is it a function? Why not? No, yeah, x sub 2 repeats, right? So it can't be one-to-one because it's not a function in the first place. Middle guy, is he a function? Yes. Is it one-to-one? No. Y. That little y2 repeats, right? Last one. Is it a function? Is it 1 to 1? Nobody's repeating. Okay? If they are 1 to 1 functions, then they are invertible. You can find inverses. And that's the key to understanding whether they're 1 to 1 or not. So if they are 1 to 1, then it does have an inverse, and we can find it. Okay? So this is the definition of an inverse function. So they call it inverse function of f. It is shown by f to the negative 1. So you can see it right here. That's the notation for inverse, or they just say f of negative 1. So you can kind of see in the little picture, little apples go in, lemons come out, and the inverse, you're going to put lemons in and you're going to get out apples. So the input becomes the output. Does that make sense? So up in the little definition, if y equals f of x, then f inverse of y is going to give you an x, because you're inputting the y and you're getting out the x. So you can see the x and y are switching positions there. Okay, in the inverse. In the inverse, the domain and range will just switch. So these 3 points are on my function. You see what happens when you do the inverse. The x and y just switch. That's key. The x and y are going to switch. Okay? That's mainly what it means to be the inverse. It's reversing it. All right, let's look how you can tell by the graph. So we already said vertical line tells you if it's a function. Fails the vertical line test, you go on. This one passes the vertical line test, which means it's a function. Fails the horizontal line test, so it's not 1 to 1. It's got to pass both the vertical and the horizontal line test to be 1 to 1. Okay? So looking at these graphs, which one, if any, are 1 to 1? Huh? The far right. None of the other ones pass horizontal line test, right? So this is 1 to 1. That one hits. That one hits. Multiples. Okay? All right. That looks like the absolute value of 2, doesn't it? It's supposed to be 1 to 1. It looks great. Here we go. 3 rules for inverse functions. So the first one we already talked about. If you input A and you get out B, in the inverse you would input B and get out A. The x and y's are going to switch. Okay? So if f of negative 3 equals 12, the inverse of 12 equals negative 3. You're just switching. The input became the output becomes the input. Okay? Easy enough? Nothing crazy there? All right. The second rule regarding inverses is the reflection of the graphs. So they will reflect, they're symmetric with respect to y equals x, which is, if you were to look at it on the graph, we don't know this line, I draw it anyway. This is the y equals x line. Okay? So because y becomes x and x becomes y equals x. Each point, 8 and 8, when you flip those, it's still 8 and 8. That is on the line of reflection, so it's not going to reflect anywhere. 3, 6 is going to become what on the inverse? 6, 3. You can see that's a reflecting point. Negative 1 stays. X and y is already equal. Negative 5, negative 2 becomes negative 2, negative 5. So if I were to graph that, you would have a reflection, yes? Okay, you just have to take key points on the graph, and all the other ones are going to reflect with it. You see now? X becomes y becomes x. Nothing crazy. The last rule regarding inverses. Last property, rule, principle, whatever. If f is 1-to-1 with the inverse of g, then this is what's going to happen. This is what we care about. If and only if f of g of x equals x and g of f of x equals x. If that's true for the domains of each individual input function, then they are inverses. So both composites, both ways, have to shrink down to an x. So when you do the composite, it should equal x at the end. Both f of g and g of f should equal x. If it doesn't, then they're not inverses. So we are verifying that two given functions are actually inverses of each other. Okay? So f of g and g of f both equal x. So let's look. So we're going to do f of g. So my f function, I'm going to input my g function. So if I am cubing a cube root, it just cancels, right? So that equals x. So we proved it one way. Now we're going to do g of f. We have the cube root of x cubed. And again, the cube root of a cube equals x. That's it. That's all you have to do is show algebraically that the inverses both equal x. Does that make sense? Because the input, which is your x, follows through and becomes the output. Okay, let's try this guy. Same idea. F of g Now there's a couple ways you can get to the next step. You could distribute the 3, or since the 3 is a numerator on the outside and the 3 in the bottom, can't I just cancel them? Say one on top and one on bottom? So I can just, get rid of those guys. So this becomes x minus 1 plus 1, which becomes x. So it's good that way. The order you do these little canceling things is important. What is my next step? And I'll tell you people who like to do things all in one step and just start crossing things out like a madman. You can't do that when you're verifying or proving something. You have to show it. Okay? So what's my next step? What can I cross off? You cannot cross the 3's off because you have pluses here. So I can get rid of the 1 minus 1, and then I can cross out the 3's because they're factors. There's a factor of 3 on the top and there's a factor of 3 on the bottom. You can't cross them out before you get rid of the 1's. So the order matters. So that becomes the next. Okay? So that's how you're going to verify that there are functions. We good? So those are the 3 rules. Now we're going to talk about how to write a function, an inverse function. So here's the steps. It's easy enough. First thing you do is say, well, I know f of x actually equals what letter? What variable can I rewrite f of x? Y. And then we said in inverse, you take the x and y and you're going to switch them, yes? So we're going to do that. We're going to switch the x and the y. So this is going to become an x, and it's going to be negative 2y plus 3. And then now your job is to get the y by itself and rewrite it in function notation. Okay? So, that's easy enough. How do you get the y by itself? Minus 3. And then divide by negative 2, right? So y is by itself now. I'm going to rewrite it in the function notation, though. Now, here's my question. Can you leave that negative by itself in the bottom? Can you have a negative 2 in the denominator? Should you have a negative 2 in the denominator? No. So what we're going to do is we're just going to change everybody's sign. As long as you change everybody's, it's legal. So now my denominator is positive. Okay? You know? You can always change everybody. You got to change everybody, though, to make it fair. All right. Moving on. Find the inverse. So, same thing we're going to do. I'm not going to rewrite it as y equals. I'm just going to say, I know this is x, and this is y. Okay, we're switching. We want to, I'm going to put my x on the other side, though. I like my y's on my left. I have a problem with putting it on the right. All right, we have two y's, one on the top, one on the bottom. So first of all, we don't want fractions. We do not want to be dealing with fractions trying to solve this. So how do you get rid of that denominator? Multiply by, right? You're basically cross-multiplying. So now we don't have a fraction to deal with. So we have y equals xy plus 3x. Everyone good with that? Okay. Now, we still have two y's, and they're on two different sides. So we've got to get them together. So let's move the xy to the left side. So we're getting closer. How do I rewrite that so I only have one y? And this is where most people kind of get stuck, and you're like, I don't know. How do you get the y by itself when there's two of them? Any ideas? Christian? You can't divide. If you divide by negative x, it would cancel in this second guy, but we would have a negative x underneath there. I think you guys don't see this next step because you don't like to do what I want you to do. It starts with an F. Factor. Do you see that it's a common factor? If I were to factor the y out, now I only have one y. Right? Now I have a single y. So anytime you have more than one y and you need just one y, factor it. Okay? So now, how do you get the y by itself? Where do you get rid of this? Yeah, divide by 1 minus x. And that's your inverse. Okay? So you have to remember, when you have these rational functions that have two x's in them, when you do the inverse, you're going to eventually have to factor out. Okay, to get the y by itself. Easy enough? A little different. Okay. Let's try another one. Okay, we have a function h that is x squared minus 1 for all x's greater than or equal to 0. Why do you think they had to say that? What does x squared minus 1 look like on a graph? Isn't he a parabola? It got dropped down one. Doesn't he look like this? Does that graph have an inverse? No, because it does not pass the horizontal line test, right? So as it is, just saying x squared minus 1, that's invertible. But if we say, you know what? I'm only interested in the positives, or the non-negatives, I should say. I'm going to restrict it to just 0 to infinity. Now is it vertical? Yeah. Okay? So go do that. Find the inverse. Switch your x and y, solve. Okay, did you get that? Getting the y squared by itself and then taking the square root. So it's only like 2 steps there. We're good? Okay. Last one. You guys try this by yourself, and then we got one more slide. Is that what we got? Yes? Does anyone else feel that there's a lot of negatives in our answer? We're positive people, right? I mean, deep down, we're positive. So I'm going to rewrite this. Now, it doesn't have to be rewritten. There just seems to be a lot of negatives. So again, as long as you change everybody, it's legal. So I changed everybody. That just seems like a nicer answer, right? They're both equivalent, though. It's technically not illegal to have 1 minus x on the bottom, like it was when we had negative 2. Okay? All right. One more slide. Can we do it? Then we'll have time to work on our take-home quiz. Okay? So, finding the domain and range of a one-to-one function. So, I'm hoping that we're all confident in looking at this guy here and telling me the domain. What's the domain of this function? So everything but negative 3, right? Everyone feels good that they can do that? Can you just look at this function and tell me the range? No. Now, I will tell you, hopefully, by the end of this year, or by December, whenever we learn this, you'll go, oh yeah, I know the range. I know the range. Y can't be negative 1. Or I'm sorry, Y can't be 1. The range is everything but 1. Okay? Now, I know a secret. I'm willing to teach you at some point. It's a magic secret. But right now, we don't know how to do that. But I do know that the inverses domain and range will switch and become, right? They switch. So if I knew the inverses domain, wouldn't that be this guy's range? The domain and ranges are going to switch, right? So if I have the inverse guy's domain and range, then, this guy becomes the function's domain. This guy is the function's range, right? All right. Sounds confusing, but let's find the inverse. Oh, we already did this, didn't we? We did this one already, but we're going to do it again. Y over y plus 3 equals x. I'm just going to kind of buzz through it because we've already done it. We're going to take the xy over. We're going to factor out the y. And we get y equals 3x over 1 minus x. So looking at this inverse, what is its domain? What's the domain of this guy? X can equal 1, right? So this guy's domain is the same as this guy's range. Since we at this point cannot find range algebraically, we're going to stick with what we know. We know how to find domain. So to find the range, you're going to find the inverse of it, then state the guys. Okay, make sense? Okay. We're not going to worry about the second one.